All right, we're going to learn a new nifty theorem. Doesn't get necessarily used a whole lot, but it's good to know in some situations. So the factor theorem, it essentially says that if you try a value and it is a factor, then we know that we can rewrite it in this form to then produce the polynomial of the least degree, or we can use that to find the zeros on a graph if we were to sketch it. So we just take this value. I think synthetic division is the easiest, but you could do long division. You could have done x plus 6 and then divide it by all of that, but I think synthetic division is the easiest. And when I did the synthetic division, it did zero out right here, so there are no remainders. So n is equal to -6 is a factor, so we know that it will, if we were to factor all of this, this would be one of the factors. All right, now the remainder theorem, kind of in the factor theorem, are tied together. What happens when you try a number and it's not a factor? This is pretty cool. This is a faster way. This is a way to do synthetic division, but faster and just with a calculator. So if we plug in -5 right here into this polynomial and we do synthetic division, so -5 times 6 is -30, 36 plus -30 is 6. You finish that off. Notice there's a remainder of 5. So -5 is not a factor. Here is the cool thing. The remainder theorem says, well, if you take -5 and where all the x's are, or in this case, where all the a's are, if you plug -5 into those, so that's what we did right here, look at what you're left with. You're also left with 5 as the answer. So if you had to do a bunch of synthetic division problems and you wanted to know if they were a factor, if that would have equaled 0, then the answer would be yes, it's a factor. And if you plug that into a calculator, it makes it a pretty fast process. All right, that's it for the factor and remainder theorem.